Hello, I'm Tanushwari Kamala, and I will be presenting my CS240 final project, where I re-implemented the classic console game Tic-Tac-Toe in MIPS assembly. Let's start by looking at how the game board is represented. The board is represented as a 9-word row major array with indices 0 through 8, mapping the cells row by row. Each of these cells represent a word. And so to access these cells, we need to first compute the index, which is done with the help of this formula. So you multiply the row index with 3 and add the column index to it. And since each of these cells represent a word, you need to multiply the index value by 4 to compute the proper memory offset so that you can access the variable from the memory. Some of the key variables in the code are the board array, which is the game state, and it's a 9-word array consisting of zeros, ones, and twos corresponding to empty, X, and O respectively. And we have the current player variable, which tells the program whose turn it is, so 1 for X and 2 for O. These are the key subroutines that the program runs on. The first drawboard goes through the 9-cell board array in row major order and prints X, O, or an underscore depending on these values. Next, the read move subroutine prompts the user for the row and column inputs and keeps doing that until the user enters valid inputs and returns the validated inputs in these registers. Next, we have the check game over subroutine, which is essentially the win-loss logic of the game. So at the end of each player turn, it loops through the entire board and checks to see if the player had won or whether the game had ended in a draw, and then exits the game if those conditions are true. Lastly, we have the switch player subroutine, which toggles the current player between 1 and 2 to switch turns. Now, I'm going to show a live demonstration of the game. Let me pull up my Mars simulator. Here you go. This is the Mars simulator. I'm going to assemble and run the program. The game starts by prompting the user to enter the row value. And if I enter any value that's out of bounds, it's going to keep asking me until I enter a valid input, as you can see. So let me give it a valid input. It's 0 and 0. And the first player X occupies this position. Now it switches to player O. So 1 and 1. Here you go. Let me try finishing the game real quick. 2, 2, 0, 2, 2, 1. Let me make player O as the winner. 2 and 0. Here you go. Player O wins. Now, let me come back to the presentation. One of the major technical hurdles that I encountered during the development of the game was off-by-factor addressing, and this was when I was writing code for the win-loss logic, and I wanted to see if the values in each column were the same, and so I took the difference between two consecutive indices in a column and used that as an offset. So let's say I wanted to compare the value in cell 2 to 5. I took the difference between both, which equals 3, and used that as an offset. So, which didn't work as expected. I realized that each cell represented a word in the array, and so the difference in the indices needed to be multiplied by 4. So taking the same example, 5 minus 2, which equals 3, multiplied by 4 bytes per word equals 12, which is the correct offset that needs to be used to access cell 5. After fixing this, everything else worked fine and the game was complete. Here are the links to the sources that helped me make the game, and this is the link to the GitHub repo that contains all the code for this project, and thank you.